Watch this video to get a quick overview of the new reference architecture for the reliable web app pattern for Java and Azure. We're going to be discussing key principles from the Azure Well-Architected Framework, looking at simplified deployments with the Dev containers and Azure Dev CLI, and diving into the retry, circuit breaker, and cache aside patterns. All the while using minimal code changes for replatforming. Let's go. First, introductions. I'm Rory Pretty, Principal Cloud Advocate for Microsoft, and I work with our product teams to help customers migrate to the cloud. I often get asked, how do other developers, take the first step to converge to the cloud? So, to help our customers' enterprise web app cloud journey, we recommend customers follow prescriptive guidance and use reference architectures, as these are built from extensive experiences helping new customers avoid common mistakes with their legacy apps. We streamline their cloud migration with these reference architectures, and we ensure successful modernization and scaling of their web applications. Our go-to prescriptive guidance for Java web apps is the reliable web app pattern. This approach is based on the Well-Architected Framework, and it emphasizes minimal code changes and reliability design patterns. It leverages managed services, infrastructure as code, and role-based security, all the time focusing on cost optimization, observability, and ingress security. We want to ensure a robust and effective application and cloud adoption. So in this video, we're going to introduce Contoso Fiber. It's a fictitious company that wishes to converge to the cloud. Their current setup includes an employee-facing app for managing customer support cases, which is an on-premise monolithic Java web app built in Spring Boot. Their challenges include, extended timelines for building and shipping new features, and difficulty scaling application components under high load. Well, the adoption phase mainly. So, Contoso Fiber really wanted to expand their on-premise customer account management system to reach other regions. Now, to meet that increased demand on the web app, they established the following goals: apply low-cost, high-value code changes, reached a service level objective, SLO, of 99.9%, adopt DevOps best practices, create cost-optimized environments, and improve reliability and security. Contoso Fiber, they determined that their on-premise infrastructure wasn't cost-effective for scaling the application. So they decided that migrating the web application to Azure was the most cost-effective way to achieve their immediate and future objectives. Contoso identified the services on the critical path of availability. They used the Azure SLOs for availability estimates. Based on the composite SLO calculation, Contoso needed an architecture to meet 99% SLO. Once they finalize the critical path, we can look at their architectural deployment. This video covers the deployment environment architecture, which is a simplified version of the full production deployment. The production deployment environment aligns to a hub and spoke network architecture to centralize common resources. This network topology provides cost savings, enhanced security, and facilitates network integration. But the full production and deployment is not covered in this workshop, and it's available on the GitHub repository if you want to go and do it. So how does this work? So first, user traffic is directed through the Azure DNS and is routed via the Azure front door. This is integrated with the Azure Web Application Firewall. This setup ensures load balancing and security, while role-based authentication is managed by Microsoft Entra ID. The requests then reach the app service plan, where access restrictions block unauthorized public internet access. The application logic runs on Azure App Service, ensuring scalability and reliability. The application interacts with Azure Database for Postgres using the flexible server option. And this is used for data management and also takes advantage of Azure Cache for Redis for caching, meeting performance and availability standards. Monitoring and logging are both handled by Azure Monitor And we use Log Analytics Workspace and Application Insights for real-time insights and diagnosis. We kind of required this by the SLO. Microsoft Entry ID manages identities, and Azure Key Vault ensures sensitive information, safeguarding the data. Contoso developers plan to use development containers to streamline their development process. This will ensure consistency across their environments and simplify the setup and maintenance of their development tools. So they've decided to pair Visual Studio Code and Dev Containers to provide a fully featured development environment, offering a convenient and robust setup. Dev Containers extension for Visual Studio Code allows you to use a container in a fully featured development environment, opening any folder inside or mounted to a container and defining tools as the runtime stack for development. The benefits include running applications and separating tools, libraries, and runtimes needed for the codebase. To use Visual Studio Code with Dev Containers, you need to first open the project folder in Visual Studio Code, and then Visual Studio Code, if it detects a devcontainer.json, will show a message saying folder contains a dev container configuration file. Reopen folder to develop in a container. Then you click on the Reopen in Container button, and Visual Studio Code will reopen the folder in the container created via the Docker file that is defined in the dev container. The title bar in Visual Studio Code will then change, indicating you are now editing in a container. This setup really allows Contoso developers to streamline their development process and ensure consistency across environments. Contoso decided to use Terraform templates to enhance efficiency, maintain consistent environments, reduce errors, and streamline infrastructure management. Infrastructure as code automates their setup, ensuring consistency and eliminating manual errors by codifying configurations. And it uses immutable infrastructure, which replaces old resources with new ones, minimizing the risk of configuration drift. Modular designs use reusable Terraform modules for consistency, streamlining their maintenance across projects. Terraform also uses state management, which tracks infrastructure state for precise adjustments, ensuring deployment accurately reflects the defined code. Contoso decided to use the Azure Developer CLI to streamline the development process and ensure best practices are followed. This CLI accelerates development, providing an open source tool for rapid deployment from a local environment to Azure. It offers best practice, developer-friendly commands, and has a key workflow stage workflow that allows you to initialize a project with a template using simple commands such as azd init, azd app, and all the while allowing you to follow best practices in a key workflow. So let's look at a nice demo that I've done. Don't worry, I have sped it up so you don't have to sit through the whole demo here. And we're going to look at how you can get started with AZD. So here I have the project, the reference architecture, and I'm going to show you that if we just start the video, we're going to start it in our dev container, reopen in container, sped up a little bit here. And this is actually going to go, AZD app, and it's going to start up our services. It's going to deploy the Terraform files. It's going to find the state, modify the state if necessary. And then once it actually is happy that we've created and provisioned all our resources, it's going to go in there and it's going to deploy your application, your Spring Boot application there. And it's going to return, there it is, deploying my service application. It's going to return the front door URL of the final entry point for our application. Obviously, this is sped up a little bit here. It takes about 20 minutes end to end though. But it really helps with knowing that developers follow that workflow. Next, we'll explore the 3 essential and powerful platforms integral to the reliable web app that Contoso decided to implement: the retry pattern, the circuit breaker pattern, and the cache aside pattern. These patterns help create a robust, resilient, and high-performing application capable of handling the various challenges that Contoso sees in their future of using their cloud environment. First, the retry pattern. Contoso plans to use the retry pattern to enhance the reliability of their applications in their cloud environment. The retry pattern handles transient faults by resending failed requests until the service is back up. It's not only about mindlessly resending requests. It also includes a delay or backoff between retries to allow for service recovery. The backoff can be a fixed or increase exponentially based on the configuration. Contoso also plans to use the circuit breaker pattern to service state and provide efficient fault handling to their applications. The circuit breaker pattern complements the retry pattern by providing additional fault handling. It retries calls in case of temporary issues and acts like an electrical circuit breaker. So just like that, if the circuit is closed, we're running smoothly, allowing requests to follow through. But if you flip it open after a failure threshold, it stops requests to prevent resource wastage. You can also ask it to enter the half state after a time, allowing limited requests. If one request succeeds, the circuit remains closed. If a request fails, the circuit stays open. Contoso plans to use the resilience for J annotations to enhance the reliability of the applications and then use the retry and circuit breaker functionality with resilience for J. The @retry annotation is part of the resilience for J library and automatically retries a call to the service plan service if it fails, making it useful for handling temporary network issues or service unavailability. The circuit breaker annotation is also part of the resilience for J library, and this helps build fault-tolerant applications by opening the circuit and stopping temporary calls if service plan fails repeatedly. So how do you start this? How do you switch it on? So we added a feature to the reference application to test these patterns and give you the ability to simulate a transient failure. The setting called Contoso Retry Demo is included in the deployable code. Contoso Retry Demo simulates the errors when the end user requests service plans with the Contoso Fiber application. This editable setting determines the number of back-to-back errors before a successful request. For example, the value of 2 generates 1 error after 1 successful response. It is also disabled by default, so to disable it, set it to 0 or remove the setting. Use the setting to observe when the circuit breaker fails due to failure thresholds. Let's have a look at how you can actually simulate this. Click on the service plans link on the left side of the Contoso Fiber application. This will try to make a query to retrieve a list of all service plans. And because the Contoso Retry Demo is set to 1, the application will return an error. Now you can navigate to this page here. Don't worry, it's all in the demo.md in the reference architecture, and you can observe the retry events. Check that out. It says there's service plan, simulated exception called when you're trying to get it. What about the circuit breaker? So the circuit breaker now needs to transition to an open state when the failure rate of the calls to the downstream system exceeds a configurable threshold. Now we've already kind of triggered that there, but in the open state, the circuit breaker stops all calls to the downstream system, and you can change that according to the setting in the reference architecture. Now in an open state, this prevents further strain on the failing service and avoids cascading failures. The open state also acts as a protective mechanism, allowing the downstream service time to recover without being overwhelmed by requests. For cache aside, we cache user details and specific settings for performance and necessity. The cache aside pattern reduces read queries to Azure Postgres Flexible Server and provides redundancy for application reliability. Caching enhances performance and scalability, offering quick data retrieval and reducing backend load. Our cache uses Redis, a fully managed in-memory data store for fast, high-performance applications. So they decided to use the caching abstraction in Spring to improve the performance of the system. In this example, we annotate the account service class to set the cache setting at the class level with the @cache config, specifying accounts as the cache name. This allows the application to quickly access updated account information from Redis, reducing the need for slower database queries. Similarly, we also see in this example that the @cache put annotation updates the cache when update account and set active methods are called. This provides redundancy, keeping parts of the application running if the Azure Postgres database has issues, and limits the read queries to the Azure Postgres Flexible Server. So how do you load the cache? So first you click on the accounts link on the left side menu of the Contoso Fiber application. Fill out the form and click on Add Account. This will create a new account and store it in the Azure Postgres Flexible Server. When successful, the account details are shown. Now, using the Redis console, which is in preview, we can see that this data is also stored in Redis. Once the Redis console is open, you can navigate the Azure Cache resources by going into the Redis console on the Azure portal and clicking on the console and typing in get and the cache details. In this case, get com.contoso.cams.account -details. And you'll see there, you can actually specify ::1, and you can get and inspect the Redis cache. So let's recap what we've learned. Reliability patterns are essential, not optional, for replatforming. While on-premise setups are more predictable, cloud environments face transient failures. By utilizing the retry, circuit breaker, and cache aside patterns, we can offer minimal code changes to maintain reliability. And we saw how Contoso Fiber can build a robust foundation for their future modernization and smooth functioning. Now, by Contoso adopting the reliable web app pattern, they will ensure their success in replatforming to Azure. You can get started now with the reference application on aka.ms/eap/rwa/java. And don't miss the next session in this series. We're going to be covering security and cost optimization. Thank you, everyone. I'm Rory Pretty, and I hope you've enjoyed this video.